Hello everybody and greetings from the Delta College Planetarium. My name is Brian and I'm here to bring you the next episode in our series about the constellations. We've been working our way through the summer constellations, but now as summer begins to wind down, it's time to turn our attention to the fall sky. The fall constellations are already rising around midnight, and throughout the autumn they will be visible through most of the night. We'll set our sky for September 4th at 1:30 a.m. facing south. During the summer, we use the summer triangle to find our constellations. In the autumn, we also use a special shape to find the constellations. Starting at the summer triangle, pick some place near the center. Doesn't matter exactly where. The shapes we're looking for are so large that we don't need to be very precise. From that point, trace a line out to the east. If your back is to Polaris, east will be to your left. That will take you to this group of 4 stars that make a nearly perfect square. Because this square is high in the sky in the autumn, we call it the Autumn Square. The Autumn Square is also called the Great Square of Pegasus because it's a major portion of the constellation Pegasus. Pegasus is a mythical winged horse. The constellation can be a little difficult to see because it's only the front half of the horse and it's upside down. The Autumn Square makes up the horse's body. This L shape of stars coming off the lower right-hand star is the head and neck. Remember, Pegasus is upside down, and coming off the upper right star, Pegasus has 2 legs stretched out in front. Pegasus is home to a star named 51 Pegasi. This faint star located near Pegasus's neck is relatively sun-like. It is slightly larger, slightly older, and slightly cooler than our Sun. This unassuming star hides an important secret that we can only see if we break its light out into its spectrum. A star's spectrum is the unique rainbow of light that it produces. Stars are hot, so they radiate light in all the colors of the visible spectrum, from red to blue. But the atoms that make up these stars like to absorb very particular wavelengths of light. Each element on the periodic table likes a specific and unique menu of light wavelengths that they will absorb. These will appear as black absorption lines in the star's spectrum. So you might end up with a star spectrum looking something like this example. 51 Pegasi's spectrum did something strange though. It moves. Those black absorption lines moved back and forth over the continuous spectrum. Were the atoms changing their light preferences? No, atoms don't do that. They will only accept very discrete wavelengths. So what else could be causing the shifting? Anyone who's ever been near when a fire truck siren has passed has probably noticed that the pitch of the siren appears to increase as the truck approaches and then quickly lowers just as the truck passes. This is the Doppler Effect, and it explains why things like sirens change the pitch observers hear depending on how the source is moving. Just like sound, light is composed of waves. Light should experience the Doppler effect too. But what is light's pitch? The light's color. The wavelength of light contracts as the source of the light moves toward the observer. Physicists say that it shifts towards the blue end of the spectrum. It's blue shifting. And when the light is emitted from something moving away from the observer, its wavelength stretches out and shifts towards the red end. It is red shifting. 51 Pegasi's spectrum shifts towards the blue, and then towards the red, and then repeats. It's going through a cycle of moving toward Earth and then moving away. It's as though the star is moving in a circle. What could make a star move in a circle? Well, gravity from an unseen companion. And from the amount of shifting present, we should be able to figure out just how much gravity is present, and therefore how much mass. For 51 Pegasi, we find that the mass is about half the mass of Jupiter. 51 Pegasi has a planet orbiting around it. 51 Pegasi B, as it is officially known, is the first planet discovered around a sun-like star outside our solar system. 51 Pegasi B, at 150 times the mass of Earth, is probably a gas giant planet. But it orbits much closer to its star than Mercury orbits the Sun. It only takes the planet about 4 Earth days to orbit 51 Pegasi. This means that 51 Pegasi B is hot. So hot it probably glows red from the heat of its star, and its atmosphere must have expanded, puffed up due to the heat. So even though it has less mass than Jupiter, it probably is larger in volume. It belongs to a class of planets called hot Jupiters, large gas giant worlds that orbit their stars very closely. This process of looking at how the spectrum of a star shifts is really good at detecting these kinds of planets, but is pretty bad at finding planets like Earth. So if it's clear where you are tonight, go out and look for the Autumn Square and Pegasus, and consider for a moment how the subtle shifts in the light of those stars can hide enormous and wonderful secrets. That's it for today. Next time we'll explore another fall constellation. This is Brian from the Delta College Planetarium, wishing you clear skies.